So this is lesson 6, session 3, page 117. And we're still working on that idea about multiplication as a comparison. Okay, so like if you have 2 cookies and your friend is like, yeah, well, I have 2 times as many as you. He's comparing how many cookies you both have, and he's saying that he has 2 times more. You can use that information to decide and find out exactly how many cookies that guy has. So for question number 1, Mia plants 8 seeds. Her sister plants 6 times as many seeds. How could you find the number of seeds Mia's sister plants? So this is our question. We need to underline our question. Then we need to find information that will help us. So we have Mia planting 8 seeds. Her sister plants 6 times as many seeds. How could you find the number of seeds? Okay, based on what we know about words and what they represent, what operation, addition, subtraction, division, or multiplication, which operation are we going to use to solve this? There are words here that tell us the answer to that, and it is times as many. This tells us that we need to multiply. Okay? So how could you find the number of seeds Mia's sister plants? You can multiply Mia's 8 seeds times her sister's 6 times as many to get 48. Now, if you're not there yet, if you're not quite understanding this multiplication part, you can draw it, okay? So the original number is 8 seeds, and then we'll label it Mia, okay? This next one is sisters. This is the amount that we're trying to find. So we don't include this in the number. We just use it as the original, and that tells me that all of my boxes are going to have 8 in them. How many boxes are we going to draw? We're going to draw 6 boxes. So 1, 2, 3, 4, 5, 6. Which number is going to be in each of these boxes? 8. So from here, you can use repeated addition. You can add 8 6 times, or you can skip count. Ooh, I think that I found a way to count by 6. 12, 18, 24, 30, and 36, 42, 48, 48. Okay, so all this equals 48. How is 4 times as many as 7 related to 7 times as many as 4? Explain your reasoning. Okay, 4 times as many as 7. 4 times 7. How is it related to 7 times as many as 4? 7 times 4. Okay, they are related because they'll have the same product. Both equations have the same product. This is the commutative property. Okay, this property is applied to multiplication or division. Okay, these numbers have the same product and they're interchangeable. You could either do 7 times 4 or 4 times 7. So this would mean you have 7 groups of 4 or 4 groups of 7. Let's write that. 7 groups of 4 or 4 groups of 7. This one goes to this one. This one goes to this one. If I'm going too fast, pause the video. If not, let's keep going. So number 3, we're going to analyze. Sergio found 4 pennies on the ground. His sister said she found 2 times as many pennies. Sergio figured out that his sister found 6 pennies. What did Sergio do wrong? Okay, so if Sergio has 4 pennies Oh, first of all, we have to underline our question. Oh my goodness. Sergio figured out that his sister found 6 pennies. What did Sergio do wrong? So let's try to solve it correctly with us. So Sergio has 4 pennies. Okay? This is the original number. His sister said she found 2 times as many. So sister has 2 groups of 4. Okay. Sergio figured out that his sister found 2 pennies. What did Sergio do wrong? Well, her sister actually found 8, but you know what I think Sergio did? Sergio just added 4 plus 2. So that's what we're going to write. We're going to write Sergio added 4 plus 2 instead of multiplying. I need to sharpen my pencil because it's hard to write neatly. So he should have multiplied, especially because it says times as many. Times as many means to multiply. You cannot just add here. If you need a second, pause it. Okay. Number 4. Paige and Ben each babysit 1 week. Paige babysits for 3 times as many hours as Ben. Ben babysits for 7 hours. Draw a bar model to represent the situation. So this is what we're being asked to do. Okay. Paige and Ben both babysit. Paige babysits 3 times as many hours. Ben babysits for 7 hours. 7 is our OG. That's our original number. So we're going to draw that here. We're going to label it Ben. I'm going to go sharpen my pencil. Okay, Ben babysits for 7 hours, and that's our original. So this one is just what our bar model is going to be using. Paige babysits for 3 times as many hours. So we're going to do Paige babysits for 3 times as many hours. Which number is going to be in each of these boxes? 7, just like the OG. Okay. So we're going to look at your model. Now write a different word problem that could also be represented by the model. Then write an equation. A different word problem. Okay. So a different word problem could be I had 7 cookies. Johnny had 3 times as many. Okay, so the reason this could work is because I could relabel this and it would use the same bar model. I could say this is how many cookies I had. Well, Johnny had 3 times as many, and this is Johnny. There's an H in there. Okay. And then the equation, how would this equation look? Or what would it look like? Okay, so 7 cookies. Johnny had 3 times as many equals 21. You do not include the original in your answer. This is not 7 times 4. This is only 7 times 3. The original number is only there to tell you what to put in each of these boxes. Draw it and then put a little line through it so that you know you're not supposed to add that in there. Number 5, show 2 ways you can think about 5 times 8 equals 40 as a comparison. So 2 different ways to use it as a comparison would be this. Okay. Bill had 8 shoes. Shannon had 5 times as many shoes as Bill. Okay, 8 shoes, 5 times as many. Okay. Now I'm going to write it the other way because this is the commutative property. They can be changed around. So now I could say Carol had 5 cookies. Daytona had 8 times as many cookies as Carol. And now we have the original being 5 with Daytona having 8 times as many. So this is a commutative property. They can be moved around. But as long as the factors are the same, 8 and 5, you're going to have the product of 40.